My name is Neil Lindsay, and I'm here to talk to you about common patterns around promises. I work for this company, Test Double, where I get to write code with a lot of great other companies. If you want your company to be one of those, you can email us at hello@testdouble.com. That's the slide to make my boss happy. He's right here, so. I'm going to start off my talk just going over the APIs of JavaScript promises, just to make sure we're all on the same page on those. And then I'm going to get into some of the good and bad patterns I see around promise code. And then I'm going to have a stunning conclusion. That's the first lie of the talk. This is just kind of a grab bag of patterns, so there's not really a conclusion. But I will go back over all the patterns that I mentioned at the end to try and cement them in your mind a little bit. But first, promises. I like to think of a promise as a container you get immediately for a value that you'll get eventually. Thinking about it as a container for a value kind of helps you zero in on the things that promises are good for. Promises are really just for asynchronous data. And that's kind of in contrast to, for instance, event handlers. Promises are not great for event handling, just in general. And promises are really not good for streaming data either. And in both of those cases, the main reason is because the then on a promise only happens once. And I'll come back to that then here in a second. A little history about promises in JavaScript. In 2010, the CommonJS working group proposed the promises/A. I don't know if they expected there to be a B or a C or something, but this was the proposal back in 2010 for how they thought that promises in JavaScript should look. And then in 2011, jQuery got all excited about promises and implemented what jQuery calls deferreds. In 2012, the promises A+ specification was released, and it basically has only been updated slightly for a few clarifications since then. It is, I think, one of the best specifications in all of computer science. You should read it. It's succinct, tells you everything that promises are supposed to do. It's very readable, so I recommend that. And then in 2013, browsers started implementing promises directly in their JavaScript engines. Really, the important takeaway from this slide is that jQuery implemented their versions of promises a year before the standard was really finished. And so jQuery's promise-like things aren't exactly the kind of promises that we have here. But luckily, you can wrap them in proper promises, and you'll be just fine. Just watch out for that. To create a promise, there is a global capital P promise constructor function available to you that you use with the new operator in JavaScript. It takes a function that gets passed resolve and reject. If everything is cool and we have the data that we want, we can call resolve to resolve our promise with a value. If things blow up, we can reject the promise with a reason. The promise constructor has a couple of helper functions on it too. If you want to just make a promise that's already resolved with a value, you can do that with promise.resolve. That's kind of a shortcut for there. And promise.reject does the same thing, but will give you a rejected promise. And you'll notice when I reject a promise, I always pass it in an error object. That's not required, but it's encouraged because other people writing promise code will probably expect to get error objects that have a message and other useful information on them. So that's a good thing to do. Once you've created your promise, the promise object itself basically just has one method called then. Then takes two functions. One of them will handle your successful case and be passed in a value. One of them will handle the error case and be passed in a reason. Only one of these two functions will be called, and whichever one gets called will only get called once. The promise specification guarantees that for you. It's discouraged to call these functions callbacks, even though they do get called back. I'm not sure exactly why promise people don't like you calling them callbacks. But it's useful to think about them differently than you would an event handler, for instance. I like to in order to avoid calling them callbacks, I like to call them handler functions. A data handler for the first one and an error handler for the second one. The then method, when you call it, it does one more thing. It returns a new promise. Every time you call then on a promise, you get back a new promise. Importantly, the old promise is not equal to the new promise. And I also promise that this is the dumbest math joke in this entire talk. But we remember when we had our constructor earlier to make a promise, we got a resolve function we could call, we got a reject function we could call. But this new promise that we got back from then, how the heck does that resolve? It resolves in one of 4 different ways. First of all, if there was no handler passed into your then for the case that happened, the first promise's state will fall through to the new promise. Both of the functions that you can pass to then are optional. So if you don't pass any functions at all, it's kind of like a no-op. These 2 statements here will do the exact same thing because that then where we don't pass any functions in, it just passes its value on to, its state onto the next promise. So that's what happens when you don't have a handler that executes. The next way they can resolve is if whatever handler function actually does get called raises an error or throws an error, the new promise will be rejected with that error object. If you return a value from your handler function, the new promise will be resolved successfully with that value, except in the special case where if you return a promise, the new promise will take on the state of that promise that you returned. This is a little bit confusing. Here I just have an example. Our new promise equals promise.then, and this function here returns a brand new promise. New promise is going to resolve with the value 3 plus whatever value p resolved with here. That's basically the entirety of the promise API, leaving out a couple tiny things. So let's jump into some patterns that I like to see in promise code. First of all, I like to make a distinction between when you're chaining your promise calls and when you're, for lack of a better word, I tried thinking of a better word, fanning your promise calls. Chaining is kind of the normal way people use promises, and you'll see this kind of code in any kind of promise documentation out there or any like intro to promises. This is the kind of thing you'll see. Here, get is some sort of function that'll probably do some sort of HTTP call to that dog URL. it's going to return a promise that we're going to call then on in order to parse the response from that get. And then that returns another promise that we can pass its value into this inline function here and do something with our dog object that we got out of json.parse. This is, like I said, this is the most common way you see promises being used, is just chaining things. But I wanted to show you what I like to call fanning your promise calls here, which can happen if you store a promise off in a variable. This is less common, but sometimes it's exactly what you need to do. Let's say we get our dog and parse them. Now we have a promise in a variable. If we want to do two things with that exact same value, we can just call then on that same promise twice. You can call then, so any individual then will only call one of its functions once, but you can call then on a promise any number of times. A more common place or way of using fanning on promises than just storing it off in like a single named variable is the case of caching promises. Promises are usually used around really expensive operations. You're usually making a call over the network that's going to take a long time, or a node, you're reading stuff from the disk, something that you just can't sit around and wait for. So it's probably pretty expensive, which makes it a really great candidate for memoization. Here we have a basic getUser with cache function that kind of memoizes our getUser function. And later on, if we get user3, we can display their name, for instance. And even further later on, if something else gets user3, it's not going to have to initiate a new HTTP request to get your user. It might already have it pulled down. It might still be in progress. The beauty of promises is that you don't care whether it's done or not. Your API for dealing with the data is the same either way. So display age might happen almost instantaneously because earlier on we got user3 in some other place. Of course, anytime you're memoizing a function that's going to access data over the network like this, you have to worry about cache invalidation. I've left that as an exercise for the reader. But yeah, this is very useful because you don't want to do those expensive network requests more often than you have to. So now that we've proved that P is not equal to NP. We talked about cache invalidation. I think the last difficult computer science problem is naming things. Promises, when I talk about like named values that I have to deal with when I'm dealing with promises, there are kind of four different kinds of values I need to name. The first two are pretty dead simple to name. The value that gets passed into your data handler function is, I usually just name it a plain old noun like I would any other variable. Here we're getting a dog from our promise. We'll just name it a dog. If you're getting a sweatshirt or if you're getting a disapproving gorilla, that'll get, just a plain old noun is fine there. Even simpler for your error handler function, you should really always just call it error. Sometimes I see people call this parameter reason, because that's how it's talked about in the promises A+ spec. The reason that things blew up gets passed into you. But I like just calling it error. And the important thing is that you always name it the same thing and are consistent with the rest of your team. And also that you force them to use the name that I prefer. A quick aside here, you'll notice I passed in undefined as the first parameter of then. That is how you, that's how you just handle errors in a then without handling your success case. Undefined is usually what people pass in there, but technically you can pass in anything that's not a function, and promises will just ignore it. If you pass in a string, that'll just get ignored by your promise. It's not going to try and execute the string or anything dumb like that. But there's a shortcut to just handling the error case. It's a method on the promise that I didn't tell you about earlier called catch. These two statements are the same. It's just the one on the bottom is a little bit easier to read. Tells you right away that we're just handling error cases right here. And then the only caveat you have is that catch used to be a reserved word, and I think it's IE 8 and 9 will blow up if you just use catch like this. If you have to support IE 8 and 9, and they are being end-of-lifed in 5 days, so that's exciting. Happy birthday to me. But if you do have to support them for some reason, you can access the catch property like this. I think all the different transpilers will actually compile your catch thing down to this. So if you're using ES6 with Babel, or if you're using CoffeeScript or whatever, this is already done for you. So the lesson is use a transpiler or drop IE 8 and 9, or preferably both. Use a transpiler and drop IE 8 and 9. Okay, that was a short digression. Back to naming things. When I'm naming my functions that return a promise, I like to use an imperative verb phrase, telling the computer, hey, guess my favorite color. Imperative verb, just because it's like we're telling the computer to do something, and verb phrase instead of just an imperative verb by itself, because it's nice to have a little hint about what you're getting back. Here when I see this function, guess favorite color, I know that the value that's coming into my data handler function is probably going to be a color. So that's nice. That gives me a nice hint around that. And the fourth, and I think trickiest to name concept in your promise code is actually variables that hold promises themselves. For those variables, I like to use a past tense verb phrase. So here I call my variable got scruffy when I get my dog Scruffy. And then later on when I do my promise chain, it's still very readable. I say got Scruffy, then do something with Scruffy. Oftentimes you'll see people say something more generic where it's just like a noun name, where they might say dog equals get dog Scruffy. And then your code down here at the bottom, your promise chain would say dog.then function dog something else. And now you have two different dog identifiers right in the same region of code. Everything gets harder to read, and you forget which variables are holding promises and which are holding just straight up values. While we're on the subject of naming things, I like to encourage people to pull out their inline functions from their promise chains and throw them into named variables for readability's sake. Here we have an example that has this just has two inline functions, but it's already getting kind of hard to read. What are we doing with Scruffy here once we get him in? We're getting the person from that corresponds to Scruffy's owner ID. Yeah, a lot of this is down to the verboseness of just function literals in JavaScript. If you're using arrow functions in ES6 style JavaScript, for instance, this isn't as big of a deal, and you can get away with a lot more inline functions. Likewise with CoffeeScript arrow functions. But as soon as you start seeing your stuff get a little bit unreadable, it's good to pull these things out into named variables so that you can pass them in. So now, by giving them names up at the top, it's easier already to see what they're doing. We're getting the owner, or we're reading a name. And then my function chain, or my promise chain down at the bottom is pretty readable. Get dog Scruffy, then get owner, then read name, then alert. Or sometimes I like to read it from the bottom up and say, I'm going to tell the user the name of the owner of Scruffy. Much more readable that way. So move your functions up into named variables. That's a very nice thing to do. But there's also another thing you can do. Is instead of having big function literals in your code, you can actually use higher order functions to generate your functions. This is kind of like a boring textbook example of a higher order function. Here we have multiply by, takes an x, it returns a function that takes a y, which returns the product of those two numbers. And that works like you would expect. And this allows us to create a times 3 function. It's not too bad. It's a little bit boring, though. If we go back to our example from a couple slides ago about getting Scruffy's owner's name, these two functions that we have up at the top are pretty readable because they have a name now, but they're also very specific to what we're doing right here in this code. They're not generic functions that we're going to use all over our project. They're probably just going to live right next to our promise chain down at the bottom there and take up a lot of space and a lot of mental load. We can actually replace those if we make a read property function. Here, this read property function will return a function that will read a property. You pass in a property name to read property, and that'll give you a brand new function that will just try to read that property name off of anything you pass into it. Now our promise chain actually got one spot longer down here at the bottom, but I think it's still very readable. Get dog Scruffy, then read property owner ID, then get person, then read property name, then alert. Or reading from the bottom up, show the user the name of the person that corresponds to the owner ID of Scruffy. And importantly, read property is a very generic function. A lot of kind of functional programming utility libraries will have something like this in it already. And you can use this all over your project, so it doesn't necessarily have to live right here by this code. The Promise API has provisions in it to recover nicely from errors. Not every error is recoverable. Some errors are just kind of stop the whole world, blow up everything, and just tell the user you're sorry that you ever existed. But some errors we can recover from, and promises let us do that pretty easily. Let's say I want to get my dog Scruffy again and show him to the user. That's all great. But presumably getDog is doing some sort of network request in the background. And what happens if Scruffy comes back 404? We can't find Scruffy at all. We could have the concept of a default dog that we use whenever the dog that we really want isn't available. Here we're going to get Fluffy anytime that Scruffy is not available. By calling catch here, get default dog is only going to get called if that first promise resolved with an error or rejected with an error. So now we have a backup dog. That's nice. But you'll notice that Fluffy is also coming across the network with the getDog method. What if Fluffy is also 404'd, or heaven forbid a 500 on Fluffy? I don't want to think about that. But it can happen. You got to prepare for these eventualities. We could have an emergency dog, Claude, that we get that doesn't require some sort of network request. I don't want to say that Claude is our dog of last resort, but he kind of is. I'm sorry, Claude. But if Scruffy and Fluffy both drop the ball, we know that Claude's going to be there for us because there's no network request going on here at all. There's not really anything that can go wrong. Thanks, Claude. Now, we've already done something a little bit wrong here in this code, which kind of leads me into the anti-patterns part of our talk. It's not really good to be inconsistent about whether or not you're returning a promise. If you have a bunch of functions that are returning promises, and then you have another function that looks like those other functions but just returns a value straight up, like getEmergencyDog, getDog and getDefaultDog are both returning promises. getEmergencyDog is just returning a straight up value. So if somebody wants to get Claude in their code, they might expect it to have a then method that they can call. So for consistency's sake, we can wrap Claude in a promise.resolve call. That's basically the main use case for promise.resolve. When you have a value that you already have, it doesn't need to come back asynchronously. Sometimes you still want to wrap it in a promise to simulate the asynchronousness, just to be consistent across your different APIs that look to your fellow programmers like they're going to be returning promises. Another anti-pattern, and probably the one that I see most often in promise code, it's really simple, but it's just unnecessary function wrapping getting thrown in your handler functions in your promise chains. Here we're getting something from the dog's URL, and we need to parse it as JSON. But you'll see my data handler function is just passing its only parameter straight onto the JSON.parse function. And the value we're returning is the value that comes back from JSON.parse. Boom, just take that extra function out of there. JSON.parse is perfectly fine to pass to the then method, and nothing could possibly go wrong with unwrapping a function like this. Oh, except slight hiccup when you're dealing with functions in JavaScript. Some functions in JavaScript want to be attached to an object and get really finicky when they're stripped off of that object. The alert function that I've been using in all these examples, even though it's kind of a terrible UI for the user, I use just because it's nice and short and gets to the point. And alert doesn't care if it's still attached to the window object. No, most of the time you don't even say window.alert, you just say alert because window is the global object. Or you just don't use alert at all, which is the actual thing you do. But what you use instead is console.log, but console.log is way more picky. It wants to be attached to that console object for some reason. If you call it this way, you'll get a type error. That's not what we want. You can fix this by kind of doing the opposite of what we just said, wrapping it in another function. This will do the job, but it's ugly. It's not really telling you much. And it's also going to be fixed by some other programmer down the line, which will recognize this as an unnecessarily function wrapping, and then things will start blowing up again, and everybody will get upset. Luckily, functions in JavaScript now have a bind method that will return a new function that just assures that your original function will get called in the context of the object that you pass in as the first parameter to bind. If you're working with a JavaScript engine that is a bit too old to have bind, there's a bind method in the underscore library that I use all the time. There are polyfills that you can get But function.bind is your friend here when you need to pass functions around, but those functions really care about the object that they're attached to. After unnecessary function wrapping, the most common bad pattern I see around promise code is just having asynchronous code that comes after your promise code. This isn't exactly wrong, but it's not exactly wrong in the same way that falling through C-style case statements without a break isn't exactly wrong either. It leads to lots of trouble. Here we're getting Scruffy and telling the user about Scruffy, and we're also telling the user good dog. But those two things happen in the opposite order that they appear in the code. All of your handler functions that you pass into then, whether they are data handlers or error handlers, will always get called asynchronously. That's something that the Promises A+ standard guarantees, and it allows you to simplify how you think about stuff. So even if getDog was one of those memoized functions like we talked about earlier, and we've actually already gotten Scruffy over the network, and we already have that value, that alert there at the top is going to execute asynchronously. So it'll happen after our good dog alert down there. If you actually want to say good dog before you tell the user about Scruffy, you can just move that alert up above. But if you have to have good dog come up after we see Scruffy, the only thing really to do is to chain another then off of your promise. Here we don't care about the value that's coming back from our previous promise. I think alert is actually just going to return undefined anyway, but we're also ignoring it. This will just assure us that these two alerts will happen in the order that we see them right here. And they can't accidentally come back in the wrong order. The reason that that's true is that the promise that's returned by the first then can't know what it's doing, whether it's resolving with the value or blowing up with an error, until that first alert function has finished executing. So we know for a fact that they're going to get the description of Scruffy first before they see good dog. Kind of the last anti-pattern that I have to talk to you about today is what I like to call inappropriately chaining queries. This can happen a lot without you even realizing it, but it's kind of hard to describe, so I'll just show you what it is. Let's say I want to take Scruffy for a walk. Here's the nice API that we have to take a dog for a walk. That's great, but my neighbor's going out of town, needs me to walk their dog also. Here we're taking Scruffy for a walk and Fluffy for a walk, but this is inefficient. I'm actually going on 2 walks now. I didn't want to do that, didn't sign up for this. My time is valuable. I only want to go on 1 walk. How can I walk Scruffy and Fluffy at the same time? The answer is this. Now, this is an answer, but it's not a very good answer. This is the code that I came up with to get Scruffy, and then get Fluffy, and then finally resolve with an array of both Scruffy and Fluffy so that I can walk them together. I'll have to modify GoWalkies in order to accept an array of dogs instead of just 1 dog, but that's easy enough to do. The real problem, and there are 2 problems here. The most obvious problem is that this is ugly. This is terrible. Oh, I lied, there are 3 problems. This is ugly. The second problem is, as soon as I have to walk a 3rd dog, this whole thing is going to get deeper. And probably the least obvious, but sometimes it's the most important problem with this kind of code, is that we're not even making our request to get Fluffy until we've already gotten Scruffy. So however long the network request takes to get Scruffy, and we have to send data down the wire, they have to find Scruffy, break him down into bits, send him back over the wire. However long that takes, we're going to have to add on the time it takes to get Fluffy before we can go for our walk. That is far from ideal. So all sorts of things bad about this solution, even though it'll work. The solution to this Gordian knot is a sword that I cleverly didn't tell you about at the beginning of the talk, promise.all. Promise.all is a nice utility function on the promise constructor that takes an array of promises and returns a promise that will get resolved with all of the values that those promises resolve with. If any of these promises reject, then the promise that we got back from promise.all will also reject. So be aware of that. When you're adding all these promises together like this, you are multiplying your chances of failing because of some sort of network error. But this gives us exactly what we want. We can get Scruffy, Fluffy, even Claude can come along with us. And we can all go for a walk together. And we really only have to wait for the slowest dog. That's the best case scenario, and we've achieved it here. And our code is a lot easier to read. Sometimes chaining your queries is what you have to do. Sometimes you need information that'll come back from your first query in order to even make your second query. Here we're getting Scruffy, Fluffy, and Claude, and then we have some sort of other function that I haven't defined for you, but that just gets the owner for each one of those dogs. We can't get the owner for the dog until we have the actual dog object. But here we have to wait for the slowest combination of dog getting and owner getting, but we still have the fastest possible walk going on. Actually, no, wait. Oh, we're not walking. Oh, I'm renegotiating my walking rates. But that'll happen as soon as possible because whichever one of these three chains resolves last, that's when I get to call renegotiate walking rates. It's time for the stunning conclusion. It's not really a conclusion. It's just me going over all the things I just talked about really quick so that hopefully you'll be a little bit more likely to remember them. And after this, I'll probably have a little time for questions. We talked about chaining versus fanning. Chaining is what you usually do with promises, but it's important to be aware of what the concept of fanning. You can call then on a promise more than once. We talked about naming the different objects that you have around promises, especially the tricky function that returns a promise naming, and especially the variable that contains the promise naming. We talked about moving our inline functions into named variables for readability, and then we turned around and replaced some of those named functions with functions that are just generated in line with higher order functions. We talked about returning promises even when you already have some static data, in the case where that will make your API more consistent. It's also important in your functions if you have two code paths that both of them return a promise and not one of them returns an immediate value and the other one returns a promise. We talked about not wrapping your functions for no reason. But we also talked about how sometimes you need to call bind on a function if it needs the context of the object that it's associated with. We talked about keeping your synchronous code above your promise code because things just get really confusing when you have it below. And then we talked about not chaining your expensive queries if you can at all avoid it. Possibly joining them all back together later on with promise.all. Thank you.